Hello and welcome, everyone. My name is Sam George. I am a group program manager on the Windows Phone team. I'm part of a team that for the last year has been building out a new native C and C++ game platform for Windows Phone. I'm here to tell you about what we did, why, and all the gory details and how you can leverage those to make money building games on Windows Phone. So as we set out to build this new gaming platform, we had a few goals in mind. The goals were based on needs that we heard from all of you and from those of you that aren't here. The first was to continue, obviously, to support our existing XNA gaming platform. For those of you that haven't heard, we changed the entire operating system. So this turned out to be a little harder than it sounded. So we spent a lot of time making sure that those XNA games kept running as is. The second was, as we talked to game developers like yourself who were coming from other platforms, the thing that we heard again and again was that taking a C++ game and moving it from another platform and targeting XNA and managed code was too high a barrier to entry. So we kept hearing that again and again and again, and that what the gaming developers we were talking to really wanted was low-level access to C++ and DirectX and on to make it easy to target Windows Phone with great games and to be able to build full, compelling cinematic games on Windows Phone. So cutting-edge performance, like I just said, obviously no big surprise from games. And then also make it easy to make money. We had a few gaps in places where people were making money, and so we wanted to make sure that we were fully competitive there. So how did we do? Well, we think we did great, or else I wouldn't be here talking to you. I'd have someone else do it. So on the first metric of reducing the cost to target Windows Phone. So one of the high order bits for that was to enable C++ code use and reuse. So we now 100% fully support C++. You can use your own C++ code. You can reuse open source C++ libraries. CocosDX and Cocos2D and SharpDX now support Windows Phone. It was very easy for them to target it now that we have this gaming platform that's more low level and like you would find on other platforms. About half of games use some form of competitive middleware, and it was very important for us as we were building this platform, not only to build a platform and wait around for people to come, but to go actively engage with these middleware vendors so that by the time we were ready to launch, that we had them all lined up so that these games could continue using them, that they use on other platforms. So we've announced support for Havok, Unity, Fmod, Scaleform, WWise, Marmalade, and more. We're really happy with the level of engagement that we've gotten so far. We've had a lot of great support from these folks. And then the next thing was, as far as lowering the cost to target Windows Phone, as long as we were going about building this new native gaming platform, we thought it would just be a little rude if we did it in a way that was different than what Windows 8 was doing, because that would make it a little hard to target both platforms. And so we built it in the same way, I'm happy to say. We have a large shared API set now with Windows 8. We have a very good story between Windows 8 and Windows Phone. I'll be talking about that in depth today, too. On the goal of enabling cutting-edge performance, we have quite an expansive C++ or API available to C++ code directly. We do provide low-level access to Direct3D 11.1, the exact same API you'll find on Windows 8. It's the same API that we use internally to build the phone experiences, so you now have access to everything we have. For audio, we support XAudio 2, Wasapi, and IMF Media Engine. I know a lot of you don't understand what those are. I'll explain those in detail. XAudio 2 in particular is the API used by console games when they target Xbox. So it is a very, very feature-rich API that allows you to do everything you need. We support video for cutscenes. We also support native networking and all the other subsystems that you'd expect from a game. So we feel like we did really well on this as well. And the last one was making it easy to make money. So one of our biggest gaps was that we didn't have the ability for in-app purchasing. We now 100% support in-app purchasing, both consumables and durables. Consumables being things like gold coins and poker chips and things like that. Durables being additional game levels. We've even made it possible for applications that are compiled against 7X to light up so that you can still have that same app running on 7X and yet take advantage of in-app purchase when it's running on Windows Phone 8. The last important part about making it easy to make money is more places to make money. So we now have a competitive global marketplace. We can sell apps and in-app purchasing in 191 countries and 50 languages. In addition to our popular mobile operator billing option, which is basically if I already have a mobile operator relationship as a user and I go to buy an app, it can literally get billed to my AT&T or Verizon account. Same with in-app purchasing. We support international credit cards now, as well as PayPal, and a bunch of local options, depending on the country. So we think we did well, and I wanted to show you some of that. As I like to say, a picture's worth 1,000 words. I'd like to announce, or I'd like to invite up to the stage Rosso Dwyer. He's head of developer support for Havok, and he's here today to show you what Havok has been doing on our new Windows 8 native gaming platform. So, Ross, welcome.
Sam, thanks so much for having us here today. So we're really happy to be part of Build. When we came here in June to the Windows Phone Summit, we announced our initial support for the Windows Phone platform. Today I'm here to reaffirm our commitment to not just the Windows Phone platform, but also to the entire Windows 8 ecosystem. And coming next month, you'll see the release of Havok 2012 with full support for our entire product range on not just Windows Phone, but also on the Windows 8 ecosystem, including Desktop, Surface RT, and Surface Professional. Havok is well known in the industry for delivering best-of-breed technology across a range of different areas. But beyond that, we're known for our relationships that we build with the customers that we work with. And over the last 14 years, we've shipped hundreds of AAA titles with those developers. We're really, really excited to see what the customers who take Havok Platinum level technology and put it onto Windows Phone are going to produce using our technology. We're really, really excited and can't wait to see what's going to happen there. Havok's all about enabling three key capabilities for our customers. The first is immersive and truly physical 3D worlds, and the second is highly realistic and interactive characters. The third is cinematic visuals. Today we're going to bring those capabilities together live running on Windows Phone, and I think we have a demo to show now. So this is the Havok Vision Engine. The Havok Vision Engine is a cross-platform engine. It's built from the ground up with professional game developers in mind. It's got a very rich feature set. It's built on top of a very flexible architecture, which is a C++ based architecture. So you can use Lua for scripting out of the gates, but as well, quite often when you're working with an engine, you're going to want to change or extend some element of the engine that you're working with. And using our C++ based component system, you can rewrite or extend whole sets of functionality within the engine. We think that's really, really powerful, and I'd like to take a look quickly at our engine editor. So this is the vForge editor. It's the editor that ships with the Vision Engine. In here, we can create all of the games. We set them up, and we can export very, very quickly to the phones. We have we have made a number of workflow changes which are specific to mobile platforms, not just the ability to preview within the editor so that we can see how it's going to render when it's on a mobile device, but we've made changes to the shader pipeline, to our particle editor. We've done a lot of work on our rendering pipeline as well to reduce the number of draw calls to make sure that rendering on mobile devices is as optimal as possible. So when we came in June, we'd only brought 2 of our products across to Windows Phone. Since then, we've brought across all of our other products as well. And while our initial experience working with the Windows Phone SDK was very positive. It's only gotten better since then. Not just because we're working inside Visual Studio 2012, which is a very comfortable environment for many engineers, and it feels very familiar. But beyond that, the DirectX 11 support provided by the Windows Phone SDK was great, because we'd done DirectX 11 work. We had a DirectX 11 render for the Vision Engine already, and so bringing that across was very, very straightforward. That, coupled with the emulator, which ships as part of the developer SDK, has been great for us. It meant that we were able to be really, really productive with a team of engineers without actually needing to have a lot of the devices in-house. Go further than that, though, and Havok is a company that's known for really, really optimizing our technology at a very low level. We work very close to the hardware, and opening up native code access inside Windows Phone 8 and the Windows Phone Developer SDK has meant that we can really get great performance from our products in a way that we weren't able to before running on phones. So that's been great. Maybe we'll take a look at a demo of this level running on the phone. So in this scene, there are 100,000 triangles being rendered. We have dynamic shaders, we have dynamic lighting, there's projective texturing, there are advanced particle effects. But beyond that, it's running Havok physics for collision detection. It's running Havok behavior and animation for controlling the animation and state machines. And it's running Havok AI for pathing the non-player characters around the world. We've been really, really pleased with the kind of performance that we can get from the phone. So having good technology is one thing. Right? Putting technology in the hands of developers is really important. But having a tool chain that's set up to help teams be productive is even more so. If you look at the cost of development these days, a lot of it is going into production pipeline, right? Creating content for your games. And the iteration and turnaround time when you start working on your game is where a lot of the cost comes from. Bringing that down is really, really important. One of the features that we have inside the Vision SDK is file serving. So we can build the game inside the tool, export to the phone, deploy the application to the phone, and then continue to modify the data inside the level and just push those changes. So we're not in a situation where we have to push all of the data up every time we want to deploy the app. That means that we bring down the turnaround time, we increase productivity, and we reduce the cost of development. So here I'm going to make some quick modifications to the scene. To delete that guy. To add in object, give it a model. Scale that up a little. Now, I spoke about being able to extend functionality, and so we had to integrate all of our technologies into the Vision Engine. And we did that exactly as we would expect our customers to use our tools. We use the component-based system, which allows you to add different components to entities inside the scene. And here we're going to use the rigid body system to turn that object, make it physical. And now when I play, that's rigid body. I have two guys in the scene, and I can go then to my mobile device. I can export the scene. I learned I need to change the res to be able to get the button. Apologies for the delay here. Okay. So when I export the scene, the previews here, it's exported the files to a file server area, and I can go to my application, reload the app, and it syncs across the changes, and I have physics running and the characters running around. Coming back again then to look at some of the tools. We've been working with AAA teams for a long time, And one of the other things that they want to be able to do is debug the game at runtime. So you have your tools here where you create your world, but then when the game is running on device, you'd like to be able to connect to it. So we have a tool called the Visual Debugger, and that allows us to connect to a game running live on a device, see what's going on inside the game, but also to record out recordings of what happened inside the game so that we can go back and debug and understand exactly what's happening. So I have one I prepared earlier, a movie of that level, and we can play that here. And here we picked up the physics and moved it around. I can pause that. I can look at the AI objects and see how they're passing. I can debug it. I can move around. And it's these kinds of tools that help make developing AAA content on phones a reality and a possibility. And we're really, really happy that we got the opportunity to work so closely with Microsoft on the Windows Phone platform. And we can't wait to see what our customers are going to do with the technology in the years ahead. If you were interested in taking a look at the tech, you can go to havok.com/build. And we also have these phones and these demos running over in Building 92. Thanks again for your time today.
Thanks,
Sam. Thanks so much.
Thank you. So it's really awesome for us to see now that we've built this platform, the kind of cutting-edge game engines like Havok, to see what they can do on top of it. So let's talk about some of the app models and APIs and start looking at some code. So at a high level, let's start first with what we've done conceptually. So in Windows Phone, what we've done is we've taken our existing XAML application model. We've added a new large, expansive Windows 8 aligned API set that includes not just a common .NET framework and a common .NET engine, the Core CLR, but a bunch of subsystems as well that are common now across phone and Windows. We've introduced a brand new application model on Windows Phone called D3D App. So you can go into Visual Studio, like I'll show you in a second, and file new project, and you see D3D App for phone. This is the same D3D App that you see on Windows 8 for store apps. And then to our XAML application model, we've made it possible. It's no longer sandbox, so we've made it possible to use C++ code inside your XAML application. And we've also added Direct3D interop so that you can have islands of Direct3D inside your XAML application, and you can draw to those directly to D3D11 from C++. So let's look quickly at D3D App. So let me just switch over. So this is Visual Studio 2012, and I'm just going to go ahead and create a new project. So under the Visual C++ node, Windows Phone, you see here under Windows Store, you see a Direct3D App. And on Windows Phone, you also see Direct3D App. So I'll go ahead and create that. It sets up a bunch of boilerplate code for me. One of the things that it does, it creates a simple cube renderer, gets me wired up with the operating system so that I get initialized, I get past a window, I can listen to input. I'll walk you through some of that in a second. But let's just go ahead and quickly hit F5 and start this in the Windows Phone emulator. So the Windows Phone emulator here is running inside of Hyper-V. It's the real phone operating system running as is. And so this is what you get with our template. It's just a quick spinning cube, but it sets up everything you need in the D3D scene to get you wired up. So I'll go ahead and stop debugging real quick. We're going to build on this one in a second, and I'll explain more about it. So the Direct3D application model is C++ only. Right now, you can't use the CLR in a Direct3D app if you want to. At some point in the future, that might be something we'll allow to light up, but right now it's C++ only. So it's not a matter of philosophy or anything like that. It provides access to a brand new Windows 8 aligned API set. This is a combination of both Windows Runtime APIs, for those of you that have seen that technology. It's automatic; those are automatically available to C# and VB, as well as C++, as well as COM and Win32 APIs. As I mentioned, you can reuse your own C++ code, either statically or dynamically, and it supports all the activation and app lifecycle events that you'd expect. Let's take a quick look at our XAML application and what we've done there. This is also something you can use to build games, and I'll explain why you'd use one over the other in a second. So with our XAML application model, you also now have C++ code reuse. You can use C++ from within a Windows runtime component in your XAML application. It also gives you full access to the Windows 8 shared API surface, including Common Win32. And we have Direct 3D composition as well. So let's talk about the Direct 3D composition. We've introduced 2 new elements to support Direct 3D composition. The first is called Drawing Surface, and this is one that you can just place anywhere in your application. You could use it inside of a list box to have each list box item have islands of Direct 3D. The Direct 3D output from this just gets automatically composited into the rest of the scene by the XAML renderer. And under the covers, it's using a Direct 3D swap chain. So there is a buffer copy happening. As you can see in the example, the XAML example, you've got a stack panel with a button and a drawing surface. So depending on the Z order, or which one comes first in the Z order, one will either be on top of the other. The other element, which is by far the more interesting one, is called Drawing Surface Background Grid. Now, Drawing Surface Background Grid is really one, it doesn't use a swap chain. You get to render to the background of this thing directly from C++ using Direct3D 11. It performs better, probably on the order of 10% better frame rate than the drawing surface. It has some special rules. It has to be the root element of a page because obviously there can't be any other background if you're the one controlling it and drawing to it. But it's just a grid. It's just a fancy grid. And so it allows you to use grid layout to lay out any of your children. Those are then automatically composited after you're done with drawing. And so let's take a quick demo of that. Switch back over. All right. So here, still under the C++ node, is the Direct3D with XAML app. It's a mixture of C++ and C#. So I'll go ahead and create one of these. Since it's a XAML application, now Visual Studio is loading the designer so that you can get a preview of what it's going to look like. And once it's done, let me move this over. So what this really gives you is 2 projects inside one solution. The first is your XAML application that hosts the drawing surface background grid or the drawing surface. And the second is a Windows runtime component that implements a certain callback interface that we use to call back into DirectX. So let's first look at the XAML and what that looks like. As you can see over here, we're using the drawing surface background grid. We've just given it an X name. So the way this works is that inside your code behind for the XAML application, there's 2 important calls. The first is to drawing surface background grid, which was just the name identifier for that drawing surface background grid. So this isn't a static. This is just an instance method called set background content provider. And what this is you're passing in a Windows runtime component that implements a certain callback interface that we call back at frame rate so that you can draw your content to the background of the drawing surface background grid. The second call is set background manipulation handler, and that is another callback interface. We'll call you back with input, either keyboard or touch input, and it's just a simple callback interface you implement. We'll walk through a little of this in a second. So when I hit F5 on this guy, it looks remarkably similar. So we have our same spinning cube, and in fact, it's the exact same cube renderer from our other template that's just running inside of here. So it's quite easy to move in between the 2. And let me just stop this for a second. So what I'm going to do is show you, to prove to you that XAML can composite on top of it in the drawing surface background grid. Let's add a little text. So I'll add a text block, and I'll give it the text, hello world. And I'll set its alignment so that it shows up in the middle. And I'll give the text color. And size. And as soon as I close my element, shows up in the designer. And then when I hit F5, you can see that the text is being composited on top of the Direct3D content. So super easy to mix and match XAML and Direct3D. So how do you choose between the two models? So just to be clear, what I'm telling you is there are two ways to build a native game on Windows Phone 8. The first is, the one that I showed you first was a Direct3D app where you're using C++ only. The second is a XAML application model. So that you'd use a XAML application model if you need access to live tiles, notifications, background agents, and XAML UI. This is useful for games where, let's say, for example, the first page is a sign-in page, and then you navigate to the next page, and that's actually your page that has a drawing surface background grid. And then after that, after the game's over, you navigate to a leaderboard page, and again, that's XAML. So if you already have your own UI framework and you don't need to bother with XAML, Direct3D app is a great app. Again, it'll perform just a little bit better. Part of the reason why is you don't have the CLR loaded in your process, which adds somewhere on the order of 5 megabytes. So not huge, but if you want to squeeze every little last bit of performance out, D3D app. XAML is a little more full-featured. It gives you access to a few of the other phone integration pieces like live tiles. In the future, you'll see Direct3D app integrating with live tiles and notifications and things like that. So it is just a matter of what we could accomplish in a one release as opposed to where we're going long term. And as far as switching between the two, like if you start out writing a D3D app and then you find, oh, actually I wanted to do a live tile and I really need that, it's not very hard at all to switch between the two. As you saw, our template is using the same cube renderer. So let's look at some of the new Windows Phone 8 APIs from the new converged API set with Windows 8. So it wouldn't be much of a game if you couldn't click on anything. So we have input. You see we have pointer pressed and pointer moved. There's no mouse anything, so a divergence from the XAML eventing that you'll see. These are Windows 8 aligned events. Also, we have a full array of sensors that are available, and you can either pull these or you can register for events on these. So if in your game loop, in your update, you want to just quickly pull and see what's going on with the accelerometer, you can do that. Or with the pointer, you can do that. Let's take a quick look at what it looks like to wire up input in your application. Switch back over. Okay. So let's open up that D3D app again. Okay, so here in my application, so one of the things I want to show you first is that this application that the template provides, it implements something called iFramework View. An iFramework View is a special interface that allows you to get bootstrapped into the system. So there's two important callbacks that iFramework View calls you back on. The first is initialize, and this will give you event handlers for things like activating and suspending and resuming. And the second is set window, which will give you your window that you can listen to events on. So let's look at the implementation for these in the template. So here you see this is the initialize callback. And here I'm listening to activated, suspending, or resuming. Activated, of course, is when your app is launched. Suspended is when it's moved to the background. And resuming is when it comes back from the background without being a fresh instance. And then set window, that's the second call. So the first one you'll get is initialize, and then you'll turn around and get a set window call. Set window is where you can get things like visibility change, whether you're closing, and where your events are happening. So here's pointer pressed and pointer moved. Pointer released is when the touch point has gone back up. This is also where you can get keyboard. So if I were to type window, arrow, you can see there's a whole bunch of events. Here's all the keyboard ones. So what I'm going to do, real quick, just to show how to wire up input, is I have this little cube renderer over here. And what I'm going to do is I'm going to change the background while the cube is spinning in response to touch. So the first thing that I'm going to do is go into my event handler for pointer released. And I'll take my member variable for the render. And I'm just going to add a little simple toggle method. And And then I'm going to go over to my render and implement that. Okay. And I'll grab a little member variable, a little bool, keep track of whether it's been set. Go back to the cube render. So now I'll initialize this to false and then implement it. You see there's been a lot of improvements to C++. I'll show you in a second that macros work. And what I'll do is, or snippets, I should say. So I have a little toggle method now. Now let's go down into the place where I'm actually doing the rendering. Now typically I'd probably do this in an update as opposed to a render, but since it's just a quick little check. So this is where the background is set. And all I'm going to do is, if this toggle is set, I'm going to change the red value. Okay. Now, when I run this guy, okay. So when I click now, it's changing the background. No huge surprise. So that's a good example of how you would get input routed into your scene. You can obviously pump it to a gesture recognizer to recognize pinch and zoom and things like that. All right. Okay, so let's talk about some of the low-level stuff. Graphics. So we support, as I mentioned, Direct3D 11.1. So while we support the same API, there are some features we don't support. This is what's known as feature levels. So feature levels are contracts of what is guaranteed to work. And we support feature level 9.3. It's a chassis requirement. So anytime someone has a Windows Phone 8 device, it will support feature level 9.3. The next slide, I'm going to show you exactly what that means. There's a few things that we don't have yet that are in Windows. These are things that we're planning on adding in the future. The first is the Windows Imaging Components, or WIC as we call it internally. This is used for image decoding. The second is Direct2D and DWrite. Fortunately, we have a story for you. For now, we have a toolkit up on Codeplex, DirectX Text, that we've recently updated to target the phone as well. So you can use this in lieu of those three technologies. Give you a chance to write that down. It's just Codeplex DirectX Text. We've also removed some legacy features on phone. Phone, for example, does not have GDI. It's a little more lightweight. D3DX isn't there, as well as fixed functions. You can use the DirectX toolkit. Again, that's up on Codeplex under DirectX K. And then we don't support runtime shader compilation, so you have to pre-compile your shaders, and for that you simply use Visual Studio. So Visual Studio fully supports shaders. We have an HLSL editor. It gives you keyword identification and things like that. Okay, so let's talk about feature level 9.3. So as you can see here on the screen, what's included. The pixel shader version that we have is very similar in syntax to shader model 4. We support long instructions of 512 instead of 256. You get dynamic flow control, gradient instructions. The max texture size is 4K. As you can see, there's a bunch of stuff that we support. There's a few things that aren't included, like geometry shaders, direct compute, resource arrays, things like that. But everything that you see that's included, again, is guaranteed to run on all the Windows Phone 8 devices. So let's take a look at what you can do with just a few of these. And so I have a demo that I'm going to show you, which just uses this subset. So let me switch over to it. Okay. Actually, let me take this off while I do my password. This is my Windows Phone. I am a parent, and so, boy, I love Kid Corner. I don't know if you guys have seen that feature, but it's definitely one of my favorites. A little plug for Kid Corner. Okay, so here's my demo. It's a popular shader demo. And this is running at somewhere around 40 FPS. This is using a bunch of shaders, just using the shader support that I just called out. As you can see, there's a bunch of blur and lighting shaders. It's just a simple model with a camera animating around it. If I click on this, you can see some of the different shader passes that are going on. So luminance pass. So quite an amazing thing that you can do with these little computers now. And quite a lot you can do with Direct3D 11. Again, this is just a native app running using DirectX. Okay, so for audio support, so that's graphics. For audio support, there's 3 different types of audio support. The first is for sound effects, which is a lot of what's used in games. We support a very rich audio API here. We have support for looping, 3D positioning, DSP effects. You can do many of them at once. You can mix them. As I mentioned, this is the same API that you would find if you were developing a console game on Xbox. And this is referred to as Xaudio 2. The next API is IMF Media Engine. This is used for background music. So if you're playing a game, a racing game, and there's music going on in the background, this is what you would use. It takes a point or two compressed audio, either in MP3 or WMA. And you can asynchronously stream it from the file system from within your Zap package, which I'm going to show you in a minute, or you can do it from a URI. And then the last is if you're interested in, if you just have PCM data and you just want to play it, you can just use there's simple APIs around Wasapi to do that. You can also capture audio using this API. So let's take a look real quickly at audio in the game world. So here's a few abstractions or a few objects in my game that I might have. I might have teammates running on one side, weapons fire going off, enemies on another side, and an explosion going off, and then an alarm going off over here. So what this might look like to the Xaudio 2 graph architecture is I have a whole bunch of memory buffers. These are PCM or ADPCM. These are what's referred to as sound voices or source voices. And each of these source voices winds up getting mixed into a mastering voice. The mastering voice is then rendered out to Wasapi. Yeah, I can have submix voices before it's mixed to the final voice. And I can have effects chains, so I can apply effects on top of those different voices. So how is that useful? So in one of the source voices might be the player's weapon, and I might change effects based on which direction it's coming from or what's obstructing it. A nearby alarm needs no obstruction. It's just going to play. For enemies behind the box, there might be a complex obstruction submix that I apply. And then there's a final mix to the output stream. So a very rich API that supports a whole bunch of options for sound in games. For background music, there's IMF Media Engine. So this is a COM API. I'm going to walk you through a quick demo of this. This is a very simple API to use. Once you get it set up, you just use a source URI or a byte stream. And you can control playback using play, pause, stop, resume, things you'd expect. Okay, so let's do a quick demo of background music. All right, so I'm going to go back into my cube renderer, and I'm going to change it so that when I click on it, in addition to changing the background music, it's just going to, or in addition to changing the background color, it's just going to play some background music as well. So I'm going to cheat a little bit so that you guys don't have to watch me add a bunch of include files. I will include first WRL, which is the Windows Runtime Library. Has a bunch of useful macros and functions for things like COM pointers. So I'm going to go into my cube renderer and add a few includes. So I just included mfmediaengine.h, and I'm going to go add a little member variable down here. So this is just a COM pointer for IMF Media Engine to my media engine. I'm going to go over into my cube renderer implementation file. And include mfapi.h. And then one of the things that is required to set up when you're setting up IMF Media Engine is it will call you back to a class instance to tell you if something's gone wrong. So we need a little quick callback. So this is what it looks like. It's just a little runtime class that implements IMF Media Engine Notify. So pretty straightforward. So what I'm going to do now is down in the part of the cube renderer where I've just set up my resources, right before it's done, I'm going to initialize IMF Media Engine. And okay, I'm going to debug through this to show you how this works. And the last thing that I'm going to do is I'm going to change my cube renderer, or my toggle method, to trigger play and pause. Okay, so here's the play method. And there's the pause method. Okay, actually I lied. One more thing to do is go into my assets folder and give it some media. So let me just minimize this guy and go and grab that. Got some music here. Oops. And I'll go add an existing item. It's going to exist in a second under assets. I'll drop this guy in here. And I make sure that its content is set to true. The content property is set to true. And all that really means is it'll copy it to your application, and it'll make it available out on the file system. Oh, one last thing. Since this is C++, I have to tell the linker which DLL to go find MF Media Engine in. So I'm going to set the input to include MFPlat. And actually, I need to do that for all platforms. There we go. All right, so let's go ahead and debug that. Okay, hit my breakpoint. Okay, so two different COM pointers, one for the class factory for IMF Media Engine, the other for some attributes. The attributes are where I store my callback class so that I can tell it where to call me back. So I'll just step through this. So as you can see, we're just calling co-create instance. And we create some attributes, set those attributes, and then create an instance of IMF Media Engine. That's initialized to my Media Engine COM pointer. So this is what our platform APIs for file system looks like. By the way, those of you looking at this kind of sideways, that little funny hat is not managed C++. For those of you that ever wrote any managed C++, that is basically a compiler way of saying this is a Windows runtime component, and it should be reference counted. That's all it really means. So here you see I'm calling a static concat method. I'm passing in the application's installed location and appending assets and music MP3. I call set source. I set looping to true, so it'll keep playing. And then when I click, let me just turn on my sound. You'll hear some sound coming out. I can turn it back off. I had better music that I wanted to show you. I wanted to rickroll everybody, but the lawyers wouldn't let me because we didn't own the rights to it, which is not cool. So anyway, there's some lame music that's playing through IMF Media Engine. So you can imagine as you're building your racing game, you can have the sound in the background. All right, let's move on. Okay, so you can also use IMF Media Engine for video. So the nice thing that we did here, we talked to game developers very early on through some early software design reviews. One of the things we heard loud and clear was for cutscenes, they didn't just want the ability to play full screen video. They also wanted the ability to composite video inside their application. So if I've got a game that has a billboard and I want video playing on the billboard that's at some perspective tilt, they said, just get out of the way, give me the frames to the video and let me put them wherever I want. So we did. So a very simple API, you initialize and set source. It looks exactly like initializing IMF Media Engine like you just saw. I can control playback with all the things you'd expect, stop, pause, things like that. And then when you're rendering video, what happens is that audio is immediately sent out along with the timed with the video. And you just get a callback that tells you when a new video frame is ready. You just grab that video frame and then you can composite it into your app. It's just a DXGI surface. It gets transferred there. And we support our RGB and NV2 or NV12 formats. So pretty straightforward to use video as well. For networking, so there's another talk that Tim Laverty has done. We're at the end of the session now, getting towards the end of build, and so I don't think Tim has another repeat of this, but it'll be available online. It goes into extensively all of the networking support that we've got. But we have everything you need to build a game. We have both StreamSocket and StreamSocket Listener, which gives you TCP sockets, including SSL support, so you can both listen on a socket and connect to one. We have datagram sockets for UDP. We even support there's a really fancy API in Windows 8 now and Windows Phone 8 called Peer Finder, which allows you to initiate a connection with another peer, either another phone or another device, and to open a socket up to it and start a communication. So you can connect app to app if you have a game running on 2 different Windows Phone 8s, or app to device, so that you can control things like helicopters and Sphero balls and things like that. For HTTP, we support a native API, which is XML HTTP Web Request 2. Gives you everything you need, all the verbs, cookie support, headers, things like that. And then one of the last things that we did is we added support for WinSock. So WinSock is a parallel and very old API for using sockets. It's existed in Windows for a long time. Now we added this because when we got some of our initial feedback, what we heard is, hey, I'm a game developer. I'm building something coming from another platform. I use open source networking libraries, and those open source networking libraries are using WinSock on Windows. And so please don't make me switch. It would be great if I could use WinSock. So we did. We added that. As far as file system, you saw a little bit of this. It's very straightforward. We have files and folders, as you would expect. We have application data. We support something called the MS AppX and MS App Data prefixes, which allow you to pass around or to start URIs. And that basically will give you a path automatically to either where your app was installed or where your data is being stored for the application. And then we have a whole mess of Win32 APIs for creating directories and files and manipulating files and things like that. Last, we support, actually not last, but close to last, we support a series of launchers and choosers. For those of you that aren't aware, on phone, you use these to initiate things like navigating to the inbox experience for web browsing or for maps, or for your application review page, or any number of things. We don't have all of the launchers and choosers. We have most of them, but we have the ones that were targeted at games. We expect to be adding more of these in the future. And if there's ones that you need that aren't there, they are all available in the XAML application model. So our good friends in Visual Studio also built a lot of great support. I don't know if you've seen, but there's a lot of new support for C++ in Visual Studio 2012, which is great to see for us C++ developers. In addition to the new templates that I showed you today for apps and components, like D3D App and D3D App with XAML apps, there's also the ability to create Windows runtime components, and these are just fancy little DLLs with metadata that get put into your application. They're automatically available to C# and VB as well as C++. And you can just create vanilla DLLs and static libraries. One of the things we also heard early on from game developers was that, yes, it's great to be able to work in Visual Studio. I definitely love it. But I also have part of my tool chain that is 100% command lines. So please make it possible for me to build, debug, and deploy all of these native games using command line tools. So again, we did. We added that. We have CPU profiling for either C++ or C#. We also support an advanced ETL-based profiling, which gives you a bunch of fancy markers that then you can look and see how your app's using the CPU. And then there's a bunch of tools now in Visual Studio for game assets. There's a mesh viewer, there's a texture editor, and I mentioned there's an HLSL editor. In the Visual, not listed here, I should have listed it, but in the Visual Studio 2012 Pro Edition, there's also a shader designer that you can get. And then these are all the talks. I'm going to open it up real quickly for questions and answers. These are all the talks that happened this week or are still going to happen. There's some tomorrow around Windows Phone 8 development. If you missed any of them, they'll be available online within 24 to 48 hours for rebroadcast. So with that, I will open it up to questions, either from myself or Russ. So. Awesome. I answered all. Oh, one question. All right.
RT.
Yes.
RT.
I'm sorry?
Is there any support for RT?
So the Direct 3D app, as I understand it on Windows 8, is supported on RT.
Okay.
Yeah. This was largely about Windows Phone 8. However, since we have the same application model running in both places, yes, it'll run on RT. Yep, over there.
So how well did the X-Audio 2 and the IM Media Engine sound systems interrupt with each other?
They both wind up going through Wasapi. They interrupt fine. Yep. You don't get pops or anything like that. Yeah. Yep, good question. The question was how well does IMF Media Engine and X-Audio 2 work together when you're using both of them, which you obviously do during games. So, yep, over here. Could you use a microphone? I'm actually having a little trouble hearing you. Thanks.
So if I have an app developed for the Surface tablet, Windows RT, so is it going to work on the phone, or just
A D3D app?
Yeah.
A D3D app. There's work to do. As I mentioned, there's a few subsystems we don't support on Windows Phone yet, like Direct2D and WIC and things like that. If you were using those, then there's a little bit of work to go and use those toolkits up on Codeplex. You wind up having to adjust for screen size and things like that, but it's very straightforward. I mean, the Havok guys are building support for both Windows 8 and Windows Phone 8, and for them, it's just a different display size.
Cool. Thank you.
Yep. Okay, for anyone that's too shy to ask a question in a group and you want to just come and talk to me afterwards, please feel free. I'll be here for quite a while, so thank you very much. I appreciate you attending, and have a great day.